This is AQA GCSE Dual Award Science. It's the chemistry topic, chemical calculations. And we're looking at part 1. This is Dual Award and Triple Science Chemistry. Going to recommend you really pause on every activity and try them on this to make sure that you are able to show your understanding of what we are looking at. So, in the first one, we're going to look at relative masses and moles. We need to know what relative atomic mass means, relative molecular mass. We're going to introduce the concept of the mole, and we're going to do some mole calculations. So we've got some questions for you to try as we go through. So look at the blue boxes and see if you can answer them. And in the first instance here, when carrying out calculations, we use relative mass rather than actual mass. This was discussed back in Chapter 1, Atomic Structure as well. And the really straightforward answer is that we use them because the actual masses are incredibly small. We're going to find out just how many atoms there are in 1 mole of a substance later on. But atoms themselves are tiny, with tiny masses. On to the next question. And again, this is an opportunity to review work that was done back in the atomic structure topic. So carbon-12 has a mass number of 12. So how many protons, neutrons and electrons does it have? Well, this is what it looks like on the periodic table. We've got a small number and a large number. The small number is the atomic number, which is the number of protons. So carbon has 6 protons. Atoms will always have an equal number of protons and electrons. So if carbon has 6 protons, it has 6 electrons. If it loses or gains electrons, it becomes an ion. It's no longer an atom. And to work out the neutrons, we need to do a little bit of a calculation. We take the mass number, which is protons and neutrons, and we subtract the atomic number, the number of protons. So we get 6 there as well. 12 take away 6. Another little bit of a recap from the atomic structure topic here. See what you can do. So chlorine is the most common isotope that you are likely to come across, and we want to know similarities and differences between isotopes of the same substance. Well, in terms of similarities, we have got the same atomic number, but isotopes have different mass numbers. Now we can bring in another similarity and difference there, because that means that there are the same number of protons, but a different number of neutrons. In terms of similarities, they have the same chemical properties. And actually, isotopes of the same element may have very slight differences in physical properties, but they are very, very similar. We're going to move on now and introduce some calculations, starting off with what isn't a calculation at all, actually. It's simply using the periodic table. So have a read of this blue box and then try to complete the table that's coming up next. So we've got here lithium with an atomic number of 3 and a mass number of 7. Its relative atomic mass is 7. So what would the relative atomic mass be for each of these? And it is as simple as finding the mass number. Remember, that's the bigger of the 2 numbers. So the first 5, 1, 9, 16, 23 and 28. I should point out actually that hydrogen is an anomaly. It's the only example where the mass number is not bigger than the atomic number. It's the same size, and that's because it has no neutrons. Okay, carrying on, chlorine, 35.5. So it is a decimal place. We take it direct from the table. 40, 7 and 39. Moving over to the other side of this table, 55, 63.5 and 75. Carrying on down, 80, 84, 108, getting to bigger numbers now. And to finish off the table, 197, 12 and 52. So that would be a very straightforward question, and it's unlikely you would get it. But we can build on that. Let's now have a look at calculating relative formula mass of a compound. Now this is slightly more complicated, but not much more complicated at all. You add together the relative atomic masses of every atom within the compound or molecule. So a couple of examples here to have a read through, unpause when you're ready. And now have a go at working out these relative formula masses. So in the first instance, we've got N2. Nitrogen has a mass number of 14. 2 14s is 28. Nitric acid, HNO3, contains a hydrogen, a nitrogen, and 3 oxygens. That's 1, 14, and 3 16s, coming to a molecular mass or formula mass of 63. H2O, water, 2 hydrogens at 1 each, and an oxygen is 16. Add those together, we get 18. Carbon dioxide, I have got a carbon with 12 and 2 oxygens with a mass number of 16, giving us a relative formula mass of 44. NH3 is ammonia, 1 nitrogen and 3 hydrogens. That's a 14 and 3 1s, giving us 17. Butane, C4H10, that's 4 carbons and 10 hydrogens, 4 12s and 10 1s is 58. Sodium tetrahydroborate, NaBH4, that's 1 sodium, 1 boron and 4 hydrogens, 23, 11 and 4 1s takes you to 38. Magnesium hydroxide, here's 1 magnesium and 2 oxygens and 2 hydrogens, because that 2 doubles everything in the brackets. So that becomes 24, 2 16s, 2 1s, giving us 58. And the most complicated one in this table, aluminium sulfate, has got 2 aluminiums, 3 sulfurs, and 12 oxygens. Add all of those together, and we get to a relative formula mass of 342. So we're now ready to introduce the concept of the mole. And to introduce it, I'm going to start with some very straightforward questions. Have a go at these and see how you do. So a dozen is 12, a fortnight is 14 days or 2 weeks, a baker's dozen is 13, a century would talk about 100, a millennium would be 1,000, and a decade would be 10. But what's the purpose of asking these questions? Well, when we talk about a mole contains a set number of atoms or elements in a substance. It's a name given to a number. When we hear the word dozen, we think 12. When we think mole, we need to be thinking 6.02 by 10 to the power of 23, because that's how many atoms or molecules there are in 1 mole of any substance. So let's have a think about this table that follows. How many lithium atoms are there in 1 mole of lithium? It's 6.02 by 10 to the power of 23. How many molecules of water are there in 1 mole of water? But it's 6.02 by 10 to the power of 23, because that's how many atoms or molecules there are of anything in 1 mole of that substance. So if I were to get a molar measurement of giraffes, how many giraffes would there be in 1 mole of giraffes? That would be 6.02 by 10 to the power of 23 giraffes. And you can see where this is going. There would be 6.02 by 10 to the power of 23 donuts in 1 mole of donuts. What we can also now do is start making links between the periodic table and what we have just learned. So have a think about what links you can make. And when you're ready, unpause. Now on this one, what I'm going to do is start by drawing out what's on the periodic table. So lithium, 3 and 7, beryllium, 4 and 9, magnesium, 12 and 24, calcium, 20 and 40. And if I start colour coding some of the numbers, lithium has a mass number of 7. 1 mole has a mass of 7 grams. Beryllium has a mass number of 9. 1 mole of beryllium has a mass of 9 grams. 1 mole of magnesium has a mass of 24 grams. Its mass number is 24. And calcium, with a mass number of 40, 1 mole has a mass of 40 grams. So we can do quite a neat summary here. 1 mole of anything has a mass in grams equal to the mass number or relative formula mass. So we learnt earlier that carbon dioxide has a relative formula mass of 44. That means that 1 mole of it has a mass of 44 grams. Now this table, or this triangle, this formula, this equation is of huge importance to you in many of the calculations that follow. Moles is mass divided by formula mass. Mass is moles times formula mass. Formula mass is mass divided by moles. And I'm going to recommend that you have a copy of that until you're comfortable with it, until you remember it. But you will need to remember and learn it. With that in mind, let's do some calculations. So calculate how many moles there are in each of the examples. Unpause when you're ready. So for magnesium, number of moles is mass divided by, in this case, atomic mass. So that's 24 grams divided by mass number 24. That means I've got 1 mole. 21 grams of lithium, well, that's 21 divided by the mass number 7. That means I've got 3 moles. 1.6 grams of calcium, that's 1.6 divided by the mass number of 40. That means I've got 0.04 moles. For water, I'm doing 18 grams divided by the relative molecular mass or formula mass. 18 divided by 18 means I've got 1 mole of water. Carbon dioxide is 4.4 divided by the relative molecular mass 44, so that's 0.1 moles. And if I have 160 grams of methane, that's 160 divided by its molecular mass of 16. 160 over 16 means I would have 10 moles of methane. Let's rearrange that equation now. Let's find the mass of each of these. So 3 moles of water, that's for mass, it's moles multiplied by molecular mass. So 3 multiplied by 18, I would have 54 grams of water. 2.5 moles of carbon dioxide, that's 2.5 multiplied by 44. That's 110 grams of carbon dioxide. Sodium, 0.05 moles. I'm going to multiply that by 23. That's 1.15 grams. Methane, with a relative molecular mass of 16, I'm going to multiply 3 by 16. That's 48 grams. If I have 10 moles of magnesium, magnesium has a mass number and therefore a relative atomic mass of 24. So 10 by 24 is 240 grams. And finally, 0.1 moles of carbon. That's 0.1 multiplied by 12. That would be 1.2 grams. And finally, to finish off this video, let's look at calculating the relative mass of a substance. So this would be mass divided by number of moles. And you can look back at the triangle to refer to that if you need to, until you can remember that with confidence. So in the first instance, I have got M divided by N, mass divided by moles. That's 54 over 3. That gives us a relative mass of 18 for A. For B, I'm doing 1.1 divided by 0.1. That gives me 11. For C, it's 32 over 2, which gives me 16. And for D, 220 over 5 gives me 44. And there is an extension here. What might they be? So they could be elements, they could be compounds, relative atomic masses, relative molecular masses. And I've put some examples in here. H2O, 16 plus 1 plus 1, has a relative molecular mass of 18. Boron has a relative atomic mass of 11. Methane, 12 plus 4 ones, has a relative molecular mass of 16. And carbon dioxide, 12 plus 16 plus 16, has a relative molecular mass of 44. So that gives us an introduction to molar calculations, ready to move on to some of the more challenging ones in the next few videos. Thank you for listening, and goodbye.